The first one is actually a question some students asked previously. If we want to make real-time forecast, then we have to consider like this chart, the x-axis, the wall clock time. And then the y-axis, the NWP model time. Take the example that we want to run a prediction that starts from hour 00 UTC. UTC is the universal time that basically is the Greenwich time. And then before you can run a numerical simulation, you have to go through step A and B before that. Step A is getting observation data. So in the world, many organizations joined the program that collects observation data, like for Hong Kong Observatory, of course, join that program and share their observation data to that organization. And then that organization will collect all data uploaded to them and then prepare it in some format common for all users to use, and then we'll put it to a download site for people who want its data to download. But for the data to be available on the download site, it may take several hours. So when the time you have that observation data ready is usually 1 hour or several hours after that time actually happened. And the second thing, after getting the observation data, some organizations have to do data assimilation, which means all the observations are usually sparse because on the surface of the Earth, usually the weather stations are only a dot on the surface. And of course, you have other observation data via remote sensing or via sounding. But sounding data is also very sparse spatially, and remote sensing data like satellite image usually have some transformation that it can only get two-dimensional image. So the problem is in numerical weather simulation, you need three-dimensional state of the atmosphere. So you have to rely on the model run before this run. For example, if this model run is done daily, you have yesterday's simulation result for this 00 hour today. And that data, that simulated data is three-dimensional. So we have a numerical, you have to use a numerical method that use the observed data to correct the three-dimensional grid data from yesterday's simulation. This numerical algorithm is called data assimilation algorithm. Usually, this is already another topic that is out of scope in this course, and there is simple method and complicated method to carry out such data assimilation. So the data assimilation program itself may also need 1 or more hours to run. So this is the time spent on data assimilation, A and B. For some organization like the United States GFS system, they will carry out data assimilation for all observation data it collects, and then run the data assimilation algorithm and put the resulting data, which often called analysis data, also to their website. And then we can download it. Basically, this is what we do in our cloud computing platform. When you order a real simulation job, we will track whether the analysis data from GFS is downloaded to our website or not. We will either trigger a download on demand, or if we find that it is not available, you will see the error message one student asked last time. So there is a time delay for the NWP before it can start. And then you have the initial condition, and you start running your time integration. And if your model is a simple model and if it has low computational cost, then the program will run fast. So you will see this slide have a pretty deep slope. Take this example. To simulate 24 hours, it used only 3 hours. So this is a practical weather forecasting. Say if you want a forecast for hour 18, you will see that before 9 o'clock, it is already available. So 9 o'clock, you can give out the forecast for 9 hours later. So this length of time is called the lead time that you can provide a forecast for a time point. How about if you use a high resolution model or you use fine mesh with high computational cost? That will be situation depicted by D and E in this figure. So the slope is less steep. And take this example, it will run from 6 o'clock to 24 o'clock. It uses 18 hours to simulate 24 hours. But adding this time delay, by the time it calculated the forecast of the 24th hour, it is already the 24th hour. So it is not a meaningful forecast to provide to citizens. This is a problem that every production site of NWP users have to face. Every site have a urgent have a need for speed. So you always need faster computer for your model to be more complicated, to use fine mesh for the forecast, and you still have lead time between the time the completion job finish, and you can analyze the results either manually or use some automated program to produce the forecast, and then to have a lead time from the time point you have the forecast to the time the forecast is ready at. So this will make you have a need to design your mesh so that the mesh can have fine mesh for the region of interest you want, and it can run as fast as possible using the least resource as possible.